Welcome again to our class again on differential calculus. We're going to look at how we can solve number 38 of UTME 2011 question of paper type D. The question says find the value of x at the minimum point of the curve y equals x to the power 3 plus x to the power 2 minus x plus 1. Yeah, this problem can be solved this way. We have y equals to x cubed plus x squared minus x plus 1. We have to find the y dx, that the first derivative of the function, and that is this 3 will come forward and multiply the function, subtracting 1 from the function, then plus the 2 come forward and multiply. Right, let me come again. Let me make it a little bit fast. The 3 will come forward and multiply the function 3x cubed. Then we must subtract 1 from the power to become what? 2. Right? Then plus these 2 comes forward and multiply the function again. We subtract 1 again from the power to have what? 2x is power 1. Then minus the power of this one, x here is what? 1. The what 1 comes forward and multiply the function x. Then we subtract 1 from the power to give us what? 0. Now the derivative of a constant is what? 0, because this one is a constant. So that gives us 3x squared plus 2x. Now x is to the power 0 is 1. 1 times 1 is 1, so that is minus 1. Alright, so that's our dy dx. Now the question is to find the value of x at the minimum point of the curve. Now we know that at the minimum point, we know that dy dx is 0. That's first condition, the first condition for a minimum function. Now, so that helps us to find the value, critical value of x. That implies that 3x squared plus 2x minus 1, which is the value that we got here for dy dx, will now be equal to what? 0. So to get x here, we have to solve this equation quadratically, because it's a quadratic equation. Now, when we solve this quadratically, we're going to find two values for x, which is x is 1 over 3 or x is minus 1. Alright, so we have those two values for x. Now we have to investigate which of these will give a minimum value of this function. Which of these will give a minimum value of this function. That takes us to the second condition of minimum and maximum point. Alright. At the minimum and maximum point, remember our x is 1 over 3, our x is what? Minus 1. The condition that we have is that second derivative, which is the square y, the x squared, must be greater than 0, that is positive, for a minimum function. If it is negative, then it is not a minimum function. Now, the square y, the x squared of what we have, the square y, the x squared, means we have to differentiate dy dx again. So that gives us 6x plus 2. Alright, when we differentiate dy dx again, these are dy dx. When we differentiate it again, we have this. Now, once we have gotten that, we now need to verify which of the value of x, that is it 1 over 3 or minus 1, that will make this positive, because it must be positive for us to take it as a minimum point. So at x equals to minus 1, 6x plus 2 becomes 6 times minus 1 plus 2, and that is minus 4. So that is maximum, it is not minimum. Then at x equals to 1 over 3, therefore, x equals to 1 over 3, we have 6x plus 2 to become 6 times 1 over 3 plus 2. And that is 2 plus 2, which is what? 4. So that is positive. So that means the value of x at the minimum point of the curve is 1 over 3. Because it is the 1 over 3 that makes the square y, the x squared, that second derivative, a positive value. If it is negative, that is maximum. If it is negative, that is minimum. So it is positive at 1 over 3 and it is negative at minus 1. So x equals to 1 over 3 is the value of x at the minimum point, point of the curve. Y equals to x to the power 3 plus x to the power 2 minus x plus 1. Right. Thank you very much. That's the end of the solution to questions, differential questions, a question on differential calculus that we have in the year 2011. The subsequent videos are going to look at the solution to differential calculus or differentiation in other years. Thank you. I wish you success.